In 2024, astronomers discovered galaxies that appeared to be older than the universe itself. Not just a little older, not within the margin of error. Some of these cosmic structures contained stars, whose light suggested they had been burning for nearly 1 billion years before the Big Bang ever happened, which of course is impossible. The universe is 13.8 billion years old. We know this. We have measured the echo of creation itself, the cosmic microwave background radiation, and worked backward to that first moment. This is settled science. And yet, when the James Webb Space Telescope turned its golden eye toward the edge of the observable universe, it found something that should not exist. Fully formed galaxies, massive, mature, burning with the light of billions of stars. All of them existing at a time when the universe was barely 3% of its current age. At a time when, according to everything we thought we knew, such structures were physically impossible. Tonight, we journey to the edge of known physics, to a place where time itself seems to break down, where galaxies defy the clock, and where the greatest telescope ever built is forcing us to ask a question that cuts to the very foundation of cosmology. What if we have the age of the universe wrong? To understand why astronomers were so shocked, we first need to understand how we know the age of the universe at all. In 1964, two radio astronomers named Arno Penzias and Robert Wilson were working at Bell Labs in New Jersey, trying to calibrate a large horn antenna. They kept picking up a persistent, annoying hiss, static that seemed to come from everywhere in the sky, day and night, regardless of which direction they pointed their equipment. They cleaned the antenna. They chased away pigeons that had nested inside. They checked every wire and connection. Nothing worked. The hiss remained. What Penzias and Wilson had accidentally discovered was the afterglow of creation itself, the cosmic microwave background radiation, the oldest light in the universe. It had been traveling for over 13 billion years, stretching and cooling as the universe expanded until it arrived as a faint microwave whisper in a New Jersey antenna. This discovery would earn them the Nobel Prize and confirm one of the most important predictions of Big Bang cosmology. By measuring this ancient light and by studying how fast the universe is expanding, scientists calculated that the Big Bang occurred approximately 13.8 billion years ago. This isn't a guess. It's been measured by satellite after satellite, refined and confirmed until the uncertainty is down to just 20 million years. In cosmic terms, we know the birthday of the universe with extraordinary precision. But here's where it gets complicated. After the Big Bang, the universe wasn't immediately filled with stars and galaxies. For the first few 100 million years, there was only darkness. Hydrogen gas slowly collapsed under gravity, pooling into denser and denser regions. The first stars, enormous, violent, short-lived, didn't ignite until perhaps 100 to 200 million years after the Big Bang. And the first true galaxies. Theoretical models suggested they wouldn't coalesce until the universe was at least 500 million to 1 billion years old. This is why what the James Webb Space Telescope found was so disturbing. It was a July night in 2022. Rohan Naidu, an astronomer at the Massachusetts Institute of Technology, was sitting at home with his girlfriend when his computer algorithm flagged something unusual. The James Webb Space Telescope had just released its first batch of scientific data. Naidu had written a program to sift through the images automatically, looking for extremely distant objects, galaxies so far away that their light had been traveling toward us since the universe was young. What the algorithm found made him call his girlfriend over to look at the screen. "This might be the most distant starlight anyone has ever seen," he told her. The object he had found, which would be named Glass Z13, appeared to exist just 300 million years after the Big Bang. That alone would have been remarkable. But what made it truly shocking was its size and brightness. This wasn't some tiny primitive clump of stars. It was a substantial galaxy, already burning with the equivalent of 1 billion suns. Days later, when Naidu and his team published their findings, the astronomical community erupted. It reverberated around the world, Naidu would later recall. Even Captain America, actor Chris Evans, shared the story on social media. But Glasses 13 was just the beginning. In the weeks and months that followed, as more JWST data poured in, astronomers found galaxy after galaxy from the cosmic dawn that seemed impossibly large, impossibly bright, impossibly mature for their age. Some appeared to have redshifts as high as 16 or even 20, placing them within just 200 million years of the Big Bang. Michael Boylan Colchin, a cosmologist at the University of Texas at Austin, summarized the problem bluntly. Even if you took everything that was available to form stars and snapped your fingers instantaneously, you still wouldn't be able to get that big that early. Headlines declared that JWST was breaking cosmology. Some researchers began to wonder if the standard model of the universe, the carefully constructed framework that had explained cosmic evolution so successfully for decades, was fundamentally wrong. In July 2024, a team led by Martín López Correduara at the Instituto de Astrofísica de Canarias published a study that pushed the problem to its most extreme. Using sophisticated stellar population models, they analyzed a sample of distant galaxies observed by JWST at a redshift of approximately 8, when the universe was only about 600 million years old. What they found was, in their words, difficult to understand in the context of standard cosmology. The stars in these galaxies appeared to be between 900 million and 2.4 billion years old. Pause on that for a moment. If the universe was only 600 million years old when we observe these galaxies, and the stars inside them are at least 900 million years old, then those stars would have had to form 300 million years before the Big Bang. In the worst case, stars 2.4 billion years old in a 600 million year old universe, they would have begun burning nearly 2 billion years before creation itself. These galaxies should instead be even younger than 290 million years on average, the researchers wrote, for which our analysis assigns a probability of only less than 3 times 10 to the negative 4th power, a 3.6 sigma tension with the standard model. In plain language, there was only about a 1 in 3,000 chance that these galaxies fit within our current understanding of the universe. López Correduara was careful to note the uncertainties involved. Stellar astrophysics contains many approximations, and dust extinction models aren't perfect. But the implication was clear. Either something was very wrong with how we age stars, or something was very wrong with our cosmic timeline. This isn't the first time astronomers have faced the paradox of objects appearing older than the universe. Just 190 light-years from Earth, in the constellation Libra, there floats a star called HD 14283. Astronomers have nicknamed it the Methuselah star, after the biblical patriarch who supposedly lived to 969 years, because, for a time, this star appeared to be older than existence itself. When scientists first measured Methuselah's age in the year 2000, using the European Space Agency's Hipparcos satellite, they calculated it to be around 16 billion years old. 16 billion years. In a 13.8 billion year old universe, the Methuselah star is a fascinating object in its own right. It rockets through our stellar neighborhood at 800,000 miles per hour, so fast that it crosses the width of the full moon every 1,500 years. Its composition tells an ancient story. Almost no iron, no heavy elements that would have been forged in earlier stellar generations. This is a relic from the very first epochs of cosmic history, a surviving ember from when the universe was young. But it couldn't be older than the universe. That was logically impossible. In 2013, Howard Bond of Pennsylvania State University led a team that used the Hubble Space Telescope to refine Methuselah's distance and properties. They revised the age estimate down to 14.46 billion years, still older than the universe, but the margin of error was plus or minus 800 million years. Put all of those ingredients together, Bond said, and you get an age that, within the uncertainty, is compatible with the age of the universe. More recent measurements have continued to adjust Methuselah's age. Some studies in 2022 and 2024 place it between 12 and 14 billion years, finally bringing it into clearer agreement with the cosmic timeline. The paradox appears to be resolved through better measurements and improved stellar models. But physicist Robert Matthews of Aston University isn't entirely satisfied. The most likely explanations for the paradox, he said, are some overlooked observational effect and/or something big missing from our understanding of the dynamics of cosmic expansion. Now, with JWST revealing galaxy after galaxy with impossible ages, Matthews's warning seems prophetic. In May 2024, the JADES collaboration, the JWST Advanced Deep Extragalactic Survey, announced a discovery that would make even Naidu's early findings look modest. The galaxy they found, designated JADES GSZ 14-0, had a confirmed redshift of 14.32. That placed it just 290 million years after the Big Bang, the most distant galaxy ever confirmed by spectroscopy. But what shocked the team wasn't its distance, it was what they found inside. JADES GSZ 14-0 is over 1,600 light-years across, not the tiny, primitive clump that theorists expected from this era. It blazes with the light of young stars, not the glow of gas falling into a black hole. And most remarkably, spectral analysis revealed strong emission lines from oxygen. Oxygen, in a galaxy existing just 290 million years after the Big Bang. The presence of oxygen so early in the life of this galaxy is a surprise, the team wrote, and suggests that multiple generations of very massive stars had already lived their lives before we observed the galaxy. Think about what that means. Oxygen isn't primordial. It doesn't come from the Big Bang. It's forged in the cores of massive stars and released when those stars explode. For oxygen to exist in this galaxy, generations of stars had to be born, live their brief, violent lives, and die in supernova explosions, all within the first 300 million years of cosmic history. Stefano Carniani of the Scuola Normale Superiore in Italy, one of the lead authors, put it simply: "It is stunning that the universe can make such a galaxy in only 300 million years. And yet, there it is, not matching any theoretical prediction, not fitting any computer simulation of how the early universe should have worked." All of these observations together tell us that JADES GSZ 14-0 is not like the types of galaxies that have been predicted by theoretical models and computer simulations to exist in the very early universe. Faced with these impossible early galaxies, some scientists have proposed a radical solution. What if the universe isn't 13.8 billion years old at all? Rajendra Gupta at the University of Ottawa has developed a model that would stretch the age of the cosmos to 26.7 billion years, nearly double the accepted value. His approach combines elements of the expanding universe with an old, largely rejected idea called tired light, along with the concept that fundamental constants of physics may have evolved over time. The discovery of well-formed galaxies at such an early stage in the history of the universe has been very disturbing for many astronomers and cosmologists, Gupta said, because nobody has a valid explanation for how they may have been formed. In Gupta's model, the time available for galaxy formation at redshift 10 becomes 5.8 billion years instead of just a few hundred million. Plenty of time for the massive, mature structures JWST is observing to develop naturally. But Gupta's hypothesis is controversial. The standard Lambda-CDM cosmological model, which incorporates dark matter and dark energy, has successfully explained an enormous range of observations: the cosmic microwave background, the distribution of galaxies, the expansion history measured by supernovae. Abandoning it would require throwing out a framework that has worked remarkably well for decades. Lopez Correduara, whose study found galaxies with seemingly impossible ages, takes a more cautious stance. If the problem is in the cosmological model, this would not necessarily mean that there was no Big Bang at the start of the universe. We would not need to throw out everything, but we would need to rethink some of its structure. Not everyone is convinced the standard model is in trouble. In 2024, Guillaume Desprez of St. Mary's University led a team that reanalyzed JWST's early galaxy observations. Using newer, more comprehensive data from the Canadian NIRISS Unbiased Cluster Survey, they searched for the same type of massive, ancient galaxies that had sparked the initial alarm. They found something important. Many of the impossible galaxies weren't what they appeared to be. When spectroscopy was performed on 5 candidate massive galaxies, all 5 turned out to have their red colors caused by strong emission lines from actively star-forming regions, not from the signature of old, evolved stellar populations. They were bright and red, but young, not ancient. The universe's age stands firm at 13.8 billion years old, Desprez's team concluded. Contrary to the early claims, we found no massive old galaxies there. If such galaxies did exist in the distant past, they must have been much less common than the early JWST results suggested. Other researchers have found that the brightness of early galaxies might be explained by astrophysics rather than new cosmology. Perhaps stars formed faster and more efficiently in the early universe. Perhaps early supermassive black holes grew more rapidly than expected. Perhaps there are feedback mechanisms between starlight and gas that we don't fully understand yet. Most people would put their money on the astrophysical explanation right now, says Mike Boylan-Colchin, who was among the first to sound the alarm about impossible early galaxies. Nashwan Sabti of Johns Hopkins University puts it more directly. We showed that Hubble really doesn't give you much wiggle room to play around with cosmology. That means the source of the ultramassive galaxies is very likely astrophysics. So where does that leave us? Do we have galaxies older than the universe or don't we? The honest answer is, we're still figuring it out. What JWST has definitively shown is that galaxy formation began earlier and proceeded faster than anyone expected. The universe was building complex, star-filled structures within its first few 100 million years, a feat that our theoretical models struggle to explain without modification. Some of the most extreme claims, galaxies with stellar populations billions of years older than the universe itself, appear to be the result of observational confusion. Young galaxies masquerading as old ones, emission lines mimicking the signatures of ancient stars. But the puzzle hasn't been entirely solved. JADES GSZ140 and galaxies like it remain deeply mysterious. Their size, their brightness, their oxygen content, all of these challenge our understanding of how fast cosmic evolution could have proceeded. And the Methuselah star still floats in our cosmic neighborhood, a reminder that measuring age, whether for stars or universes, is harder than it might seem. The coming years will bring more JWST data, more spectroscopic confirmations, more refined stellar models. Brant Robertson of UC Santa Cruz, one of the JADES team leaders, is optimistic. We could have detected this galaxy even if it were 10 times fainter, which means that we could see other examples yet earlier in the universe, probably into the first 200 million years. The telescope hasn't reached its limits. The early universe still has more secrets to reveal. There's something profound about the fact that our most advanced scientific instrument has created more questions than it has answered. We built the James Webb Space Telescope to peer back to the dawn of cosmic time, to watch galaxies being born, to witness the first light after the darkness that followed the Big Bang. We expected to find primitive, small, simple structures, the cosmic equivalent of single-celled organisms. Instead, we found galaxies that seemed too big, too bright, too complex, and sometimes seemingly too old. We found evidence that the universe was doing extraordinary things in its first few 100 million years, things our best theories didn't predict. Some will see this as a crisis. The headlines certainly treated it that way. But to scientists, this is exactly what discovery looks like. The universe is under no obligation to match our expectations. It simply is what it is, and our job is to understand it, not to fit it into boxes we've already built. The age of the universe may indeed be 13.8 billion years. The evidence for that number remains strong. But how the universe spent its first few 100 million years, how it built stars and galaxies, and the scaffolding for everything that would come after, that story is being rewritten before our eyes. We stand at a remarkable moment. For the first time in human history, we can see light from the cosmic dawn. We can watch galaxies coalesce from the primordial hydrogen that filled the infant universe. We can, in a very real sense, look back in time to witness creation. And what we're seeing is stranger, more wonderful, and more puzzling than we ever imagined. The universe keeps its secrets reluctantly, but slowly, patiently, persistently, we are learning to read the light. If this journey to the edge of cosmic time left you with more questions than answers, that means you're paying attention. Subscribe, and we'll explore the universe's deepest mysteries together.